good morning and welcome. The title of the present work is Maple for Distance Education in Secondary Schools During the Emergency from Covid-19. This is a joint work between Cecilia Fissore, Francesco Floris, Marina Marchisio and Matteo Sacchet from the University of Turin. Let me tell you something about the University of Turin. Founded in 1404, the University of Turin is one of the most ancient and most prestigious Italian universities. Hosting about 79,000 students, the university is today one of the largest Italian universities open to international and research and training. It carries out scientific research and organizes courses in all disciplines except from engineering and architecture. Inside the University of Turin, there is the research group called Delta. It's a group that works in digital education for learning and teaching advances. It is a group composed by different areas of expertise, from computer science to languages and mathematics. And that's why the talk of today is about the use of Maple in education. The situation in Italy due to the Covid-19 pandemic. As UNESCO reports, most governments around the world have temporarily closed educational institutions to contain the spread of the Covid-19 pandemic. In Italy, schools were closed in early March until the end of the school year in June. All teachers took action to facilitate continuity of education through remote learning with the use of technological methods and tools, like the digital learning environment. All schools have reopened by the end of September 2020, and classes are taking place face-to-face. However, due to the uncertainty of the situation, teachers must be prepared for blended learning. The main support comes from the Ministry of Education. It provided teachers with a site for distance learning in the national framework of the problem posing and solving action. The national project Problem Posing and Solving. It is a national project promoted by the Ministry of Education, whose main aim is to improve learning and teaching STEM, so science, engineering, technology and mathematics, with technology. The project wants to adopt innovative methodologies, so teachers can use problem posing and solving with Maple. They can adopt automatic formative assessment, or also collaborative learning among teachers and students. There are also training activities for teachers. The enrollment in this project is free of charge, and there is constant support in adopting methodologies and training activities. This is the context of the research that we're carrying out. The project involves the use of an integrated digital learning environment. This environment is dedicated for STEM education. It is a Moodle platform integrated with Maple for the creation of interactive materials to help the exploration of mathematical concepts and developing problem posing and solving skills. Teachers use the DLA in their daily teaching activities. They use it before the emergency and continue to use it fully online during the emergency. For these teachers, in the problem posing and solving project, it was easier to switch to online teaching. Teachers use Maple before the emergency in different ways, carrying out problem-solving activities in computer labs or in groups or individually, making students submit their work created with Maple projecting the interactive files in class through the interactive whiteboard for a theoretical explanation or an exploratory activity, or for uploading interactive materials on the DLE for asynchronous activities. During the emergency, Maple not only provided a useful tool for dealing with forced distant teaching more easily, but it showed to be a very convenient tool, flexible for new modalities and new purposes, like synchronous online lessons, formative online assessment, adaptive activities for students with difficulties. That's why, in this research, we asked ourselves this question: what kind of support can Maple integrated in a DLE give for distance education? In order to answer this question, these methodologies are applied: a quantitative analysis, checking 74 courses held by 40 teachers. For each course, the number of Maple worksheets was reported, and we wanted to understand how much they had used the resource with the students. On the other side, we carried a qualitative analysis to study for what purpose these resources were used, and to understand the potential and the effectiveness that Maple resources can give to STEM education. Let's start with the quantitative analysis. A total number of 1,289 Maple worksheets were uploaded in the 74 courses, ranging from 3 worksheets in a course to 138 in a course. On average, 27% of course materials are Maple worksheets, ranging from 5% to 84%. There are teachers who have conducted the entire course with the Maple worksheet resource, and teachers who have rarely used it. In the pie chart on the right, you can see the percentages of classes, ranging from 5 to 24%. We have 46% of teachers, so there is half of them that rarely, let's say, use the worksheet resource. But the remaining 50% used Maple research activities more than 25% of the total course resource. And there is a 8% of teachers who adopted for the entire course, more or less. Let's jump to the qualitative analysis. For each course, the Maple worksheets were classified according to the categories: contextualized problem-solving activities, in-depth theoretical explanation, interactive resources for mathematical exploration, explanation of Maple commands, text of exercises and resolution. In the next slides, we are going to focus on each of the 5 categories. Example of contextualized problem-solving activities. Teachers propose students the resolution of a problem with Maple and the generalization of the solution process. This is in line with the problem solving, which is the main focus of the project, with an advanced computing environment. All problems are contextualized in real-life situations. This one considers a problem about a circular sector. The problem is taken from the movie The Golden Compass. Teachers use interactive components to develop computational thinking, and they focus more on the process of the resolution and not so much on the calculation. Example of in-depth theoretical explanations. These theoretical explanations, which of course contain a lot of text, are enriched with animated graphs and interactive components, making it easier to students to understand some processes. These worksheets enrich the textbooks and provide also illustrations and interaction. These two worksheets are about lines, for example, about parallel lines, perpendicular lines, and so on. And the right one is about the limit of a function. Example of interactive resources for mathematical exploration. These worksheets are something similar of the math applications in Maple. So these worksheets provide interactive exploration with immediate feedback, and they explain mathematical concepts to support the study or for modeling activities. These math apps, let me call them like this, are completely developed by teachers. The title is in Italian, even in these worksheets, because this project involves Italian teachers. And the left worksheets deal about the calculation of areas, while the right one deals with the properties of a triangle. Example of explanation of Maple commands. Some teachers used Maple worksheets to explain Maple itself, with step-by-step explanations and also video pills. We have to stress that these videos are not taken into account in this research because they're not provided through Maple worksheets. Students can download and use the Maple worksheet, of course, and they can modify, edit, or create new outputs in the worksheets. They are useful for solving exercises and for study support. Example of text of exercises and resolution. In this case, Maple is used as a text editor to assign exercises to students and to propose solutions and resolutions. So this is quite an easy way to use Maple, but it is anyway useful for students because they can find a resolution of exercises. Some results from the qualitative analysis. 66% of teachers use more than one type, one category of worksheet, adopting different teaching methods, depending, of course, on the purpose of the activity. In the table below, there are details about the number of teachers who use worksheet of for problem solving, for theoretical explanation, and so on. While the second row of the table shows the total of worksheet of this type inside the course. So, for example, there are 27% of problem-solving worksheets on the total of 1,289 worksheets. So, more than half of the worksheets are about problem solving and interactive exploration activities. While we have to stress that few worksheets, about 9%, are used for exercises. The pie chart on the top right shows the number of type of worksheets used by teachers. So for example, 34% of teachers use just one kind of worksheet, while 18% of teachers, so 1/5 teachers, used all the categories of worksheets that we showed. The results are shown in this table because we wanted to look for pattern in the usage of different kind of worksheet categories. The last column of this table shows that 13 teachers used all the categories of worksheets for problem-solving activities, for theoretical explanation, for maple explanation, for interactive resources, and for exercises. This was the most common pattern, using all the categories. The second pattern, ranging from the number of teachers, is just about problem-solving activities, which was adopted by 9 teachers. And the third one is just the interactive resource pattern, just this category, which was adopted by 8 teachers. The other one are decreasing in number of teachers that adopted this pattern and are using, of course, less categories while going down. But this stress that the problem-solving activities and the interactive resources were the most common ways of using Maple. Let's go to the conclusions. Teachers use Maple significantly to propose different activities using different methodologies. The most appreciated feature by Maple teachers are the interactive components used for theoretical explanations, exploration of mathematical concepts, and for the generalization of solution processes in problem-solving activities. The integrated digital learning environment allows to maintain the interactivity of Maple files and to make them available to students, even to students that do not own the software. Students who own the software, of course, are facilitated in downloading also the Maple worksheets and modify what teachers have provided them. Not being able to teach Maple in the school computer lab, some teachers have designed files with step-by-step explanation for students to use the software independently at home. This type of resource, the Maple worksheet, online Maple worksheet, can enrich STEM teaching and learning at any level of education. Thank you for your attention. These are the contacts of the authors.